Good morning, ladies and gentlemen of Precalculus. Good to have everybody here today. I hope Riley's okay. Are you okay today? Yes. Okay, good to hear. All right, what we're going to do is, we left off, I think, with problem 37 yesterday. Does that sound familiar?
Yeah.
And that was that bungee tree. And so now we get to, so this is number 37, all worked out from yesterday. We have an arithmetic sequence here, and we have the first four terms, and then we use our formula, and that formula being this one right here to get our 51st and 52nd week tree size. So we're going to be looking at more of the formulas today.
Can I have that paper?
You were not here yesterday? Were you here yesterday? You were here, weren't you? Oh, you leave?
I had to leave. I had to go to West Virginia.
Oh, that's right. Yeah, you did leave. That's
I
right.
lost mine.
Okay. So what I want to do next is go to problem 39. And one reason I want to go to 39 is it so happens that on your final, there's a problem that's very much like 39. So we're going to do this problem and kind of expand upon that so as to emulate what you're going to see on your test. Okay, so we have this is one of the classic, it's a arithmetic series problem. So they make up these real world problems, and this is just a classic problem that you'll see everywhere. And there are other versions of this. Sometimes it can be stacking cans in a grocery store, in a pyramid, or other types of similar geometric relationships. So we have the first row of seating in section J of Athena Arena has 7 seats. In all, there are 25 rows of seats in section J, each row containing 2 more seats than the row preceding it. How many seats are in section J? What would you do with a problem like this?
Multiply 25 and 7 to get total.
Okay, so if we take 25 by 7, we would have that. Okay, that's a strategy. But what we have is the first row is like this, 2, 3, 4, 5, 6, 7. And it says each row containing 2 more seats than the row preceding it. So this is row 1.
I would probably draw it.
That's row 1. Yeah, that's one strategy. In row 2, it's going to have 2 more seats than that. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And similarly, we could draw row 3 and draw 11 here. 3, 4, 5, 6, 7, 8, 9, 10, 11, right?
You could do 7 times 2, or whatever. 7 times 25, and that times 2.
7 times 25 and that times 2. Well,
Oh.
what we're going to do is, the strategy is to know a couple things. One is to know what a sub 1 is, and a sub 1 in this case is equal to 7. And then we need to know a sub 25. That's what we need to know. I mean, that's one of the things we need to know. So how do you find how many seats we have in the 25th row? Let's go to our formula, in the formula chart. And here is said formula right here. You remember using this several times yesterday? I hope. Justin, you remember using that formula? It's on your ACP
Yeah.
formula chart. Yeah. So A sub 25, oh, by the way, what is our D? What is our common difference here?
2.
2. So A sub 25 equals A sub 1, 7 plus D times n minus 1. Well, n is 25, right? So we can just multiply this by 24. And so now we work that out, and that's 2 times, that's 48 plus 7, that's 55, isn't it? That's 48 plus 7, does that look right? Okay. So this is how many are, this is A sub 25, this is A sub 1. And so next I'm going to tell you so this is going to be our 25th row, this 7 seats is in the first row. And we're going to access another formula here, and it's this one right here. Sum of a finite arithmetic series. Do you see that formula here? Okay. So, and then we have this little thing on the left, this sigma, and that gets into calculator applications. But we have n over 2 times actually, this is A1 plus A sub n over 2. So it's the average of A1 and the first row and the last row times the total number of rows. So that's what it is. So let's go to that. So let's see, yeah, I'll just write it in the notation here. So sigma of A sub k, we'll call it, is equal to n. I'll just write the formula, n times A sub 1 plus A sub n.
The
775.
formula that you circled on the chart doesn't match that.
What? This one here?
Yeah, the one above it. The formula that you circled on the chart doesn't match it.
Really? Let's take a look. Maybe I'm hallucinating. Yeah, it's the same one, but the only thing is I put D over here.
Why would you put D over there if you're supposed to multiply?
It's all the same thing.
So you can, like this formula multiplies from the right side. The way I wrote it, I put 2 over here.
But you don't get the same one.
Okay, if you take, this is going to be 24 right here, right?
So then it should be 7 plus.
7, this is 7 plus 2 times 24. It's 55. Okay?
Yeah, I know.
Are you okay with that?
Yeah.
All right. But that's good to bring it to my attention. I can't answer questions if you don't ask them. Thank you. Okay. So now here we are back to this formula, and Nicole says she has it. So there's 25 rows, n times A sub 1 plus A sub n, and it's going to be the average of that, so over 2. So what did you say it was, Nicole?
775.
775. So that's what it's going to be, 775 seats. And what happens over the years when we've had problems like this, do you know what I've seen on people's tests?
Is it this? Or they're just counting?
Yeah.
Okay, that's what I did.
Yeah, see, so what I see on people's tests is what Nicole did. They have the diagrams with everything written out instead of using the formulas. Can you get it right this way?
Yes.
And when we're in that test next week and you ask me for a piece of scratch paper and you write it out like this and you take the time to get it right, are you still going to get it right?
Yes.
Yes. But the idea we have here is I want you to, if you can, get comfortable with the formulas. And this is a classic problem I had in the history of mathematics, there was this great mathematician. His name was Friedrich Gauss in Germany. And he was one of these bright kids that would keep on bothering the teacher for more, like they give him an assignment, he'd give him an assignment, he'd be done. And he says, okay, here Frederick, what I need you to do is take the numbers 1 through 100 and add them all up. And he was hoping to get rid of them for some time. And he comes back a second later, well, this is what it is, here's the answer. And he used this method right here. So a little kid, genius little kid, figured it out. So that's history of mathematics. But does this make sense?
Yeah.
Okay, any questions on this? Okay, and this notation, this summation notation, we're going to get more into that today, including calculator. So really, that's all I want you to do on this exercise sheet so far. So really, only 2 problems, right? 37 and 39.
There's one from yesterday.
Oh, from yesterday?
I put it in my bag and then I'll. Yeah.
So both of these.
That's today.
That's good.
Do we need to
Yeah, today.
Mr. G, you want me to just take this thing and
I feel bad giving you.
Right.
critical
That's all.
thinking.
That's all that you do.
Okay. And on this one, do I do all of them?
I think we did all of them except for maybe the last one. Is that right? This one here, we did all of them except for the last one. Yeah, I think we did everything except the last one. So that's like, that'll be on the video from the class. And you have that, right? Yeah, that's just good. That's yesterday's class. Okay, very good, ladies and gentlemen. We will get going on this. Okay. So we go to this one right here. Okay, and 1 through 4, A sub n is arithmetic. Use the given information to find A sub 10. And I may want to skip over a couple of these to go for time. Yeah, let's just do 1 and 2 here on this set. Okay, and I guess I could probably call on somebody for this one, can't I? Right, you'd be okay with that? Yeah, let's do that. Because this is the quick review, and we're getting into, today we're starting on series, and really problem 39 was like our first series problem. And series is where you add up the numbers in the sequence. That's what a series is. There it is, 5th. It's right here. Okay. Number 1 looks like Karina's got number 1. All right, Karina, what do you think? So A sub n equals 4 plus 2 is n minus 1? Yeah, so Chloe, what it is, the formula in the chart has that D over here on the other side. So that's it. But it was right if you'd pointed out. I appreciate you doing it. Okay, go ahead, Karina.
And then 8, 10,
Equals 4 plus 2 times, that's going to be 9, right? So that'll be 22. Okay? Does that sound right? Okay, do problem number 2. I'll call on somebody to do problem 2 in just a minute. All right. Problem 2. All right, we will have another victim here. This will be Robert. In regular order of things here, Robert. Okay, Robert, what do you think?
Okay, so n equals 3 minus 2.
3 minus,
Because that's A1, it says equals 3, and
Okay.
A2 equals 1
so minus 2.
times 10 minus 1.
Oh, 10 minus 1. You want to put 10 minus 1? Okay, I'll do that. Let's
Is
just
that
put
the one with 10?
10 minus 1. So here what Robert did is he used the information and he figured out that our D is going to be equal to negative 2, right? And then he applies the formula, and so you got 3 minus, that's going to be 2 times 2, 3 minus 18, is that what you got? Which equals
Negative 15.
negative 15.
Where did you get 8?
2 times 9.
Yeah, so that's 9, this is 9, and 2 times 9 is
You gotta get out.
A1
18.
is 3.
Oh,
Okay, good job, good job. I appreciate that you did that because I thought you answered some questions too. Okay, I want to go on, I want to skip those next two and go on to the number 5. Yeah, and so 3 and 4 require more figuring essentially to get them. That's all it is. They're not so bad, but. So now we're given the geometric sequences used to find a sub 10. So I'll go ahead and spin this and see how we do on this. Now remember that R is equal to a sub n divided by a sub n minus 1. So that's a key sub-formula that could help with this. Okay, let's see here. It's going to be Riley. Riley, you were not here yesterday. How are you on problems like this?
I'm kind of confused.
Okay, let me show you something. Okay, this is your geometric sequence thing, right over here, which is a different formula, but it has similarities. So a sub n equals a sub 1 times r to the power of n minus 1. So how do you find out what r is? In this case, r is going to be equal to,
Plus 1.
r is equal to a sub n over a sub n minus 1. So r is equal to 2. So that's going to be it. So now, Riley, you can use the formula to find a sub 10, right? So we know our initial we know that a sub 1 is 1, so that's like our initial value,
So it'd be a sub 10 equals 1 times 2
1 times
Power of
2
10 minus
power-
1.
to the power of 10 minus 1. I think that's it, isn't it? That's it. So let's go ahead and figure that out. A sub 10 is equal to, that'll be 2 to the 9th power. 512? Okay, anybody else get
I
that?
don't think that's right.
You don't think it's right?
It is.
It is?
I thought a sub n was 1.
Well, a sub 1 is 1. A sub n is indeterminate, right? And so basically, a sub n is equal to 1 times 2 to the power of n minus 1.
I know, over there in the equation, r equals a sub n over a sub n minus 1.
Well, like this?
Yeah.
Yeah, this is a way of saying, all this is, it's just one way of articulating that all this means is you take a term and divide it by its predecessing term. So that means you're taking 2 divided by, so a sub n in this sub-formula is 2, and a sub n minus 1 is 1. So that's just one way of articulating two terms, successive terms.
Okay.
That's all that is. Okay? All right, good job, thank you, Riley. See, Riley wasn't here yesterday, but she came with attitude. Okay. I'll work through this. I think I'll choose somebody for number 6 here. All right, so here it is. You got a sub, yeah, this is one where you have to do a little backfilling. Well, we'll see how it goes. I think there's some learning to be done here on this one. All right, Becky. We have our reindeer, Becky. Becky's, by the way, dressed in her reindeer headgear today. We got our Christmas hats on today. See, I have my Christmas hat on today. See that? Kind of like a Santa's elf sort of hat. Becky has like the reindeer antlers. Okay, Becky, what do you think? Want me to draw a picture for you? Let me draw a picture. Okay, the similar to pictures we drew yesterday. Okay, we have n, a sub n. So I'm going to put 4, 1, 6, 2. So, how far apart are these things on the left? 2. And what's the ratio here? What's 2 divided by 1? 2. Okay? So basically what you have is you have r squared is equal to 2.
R squared.
Yeah. And the reason is these are 2 apart here. Okay, so I don't have 5. I don't have that. But I know these are 2 apart. So what is r going to be? Vicky's over there thinking, and other people are thinking, boy, I'm glad I didn't get that one. What do you think, Robert? Pardon me? What is R?
2.
No, R squared is 2. What is R? 1.4? Yeah. So what it's going to be, it's going to be square root of 2. Okay, anything else besides that? There is something else. What else besides square root of 2? What is it going to be? Yeah, okay, Karina got that. Plus or minus square root of 2. Plus or minus, so it's really indeterminate. So now what we could do is we could use the recursive rule. We know what the rule is, that we have 8. We know that at 8 we're going to have another times 2, right? And at 10, we want to find a sub 10 would be another times 2. So what's 2 times 2?
4.
And what's 4 times 2? 8. Okay, so in this case, a sub 10 is going to be 8. Now, if they were really sneaky about it, they could have said, "What is a sub 9?" And then we would have had to say plus or minus something. But a sub 10 equals 8. Now, this was not an easy problem compared to the others, right? So that's just what it is. But you see how we come up with that? That's similar to what we've done before somewhat. Okay. Okay, this one here should actually be a little easier even. Find a sub 10. Yeah. Wait a second. Yeah, it should be. Okay. Okay, I want to choose somebody for this one too, in just half a minute. To me, I think this one here, I think it's simpler than number 6. That's okay, yeah, it's okay to be wrong, right? Okay, here we go. Be Justin or Nicole, be Justin. All right, Justin. That's right, he's good. Thought he'd come back. I was looking at the wrong person.
And it's Nicole.
She's nice again.
Elizabeth, better be you. Please be Elizabeth.
All right, Chloe, you ready to work? You should have had it for you. Okay.
I know ace of 1 is 17.
What'd you say?
I know ace of 1 is 17. Justin's back, you can do it.
How did you get ace of 1 equals 17?
Because I started at 5 and I added 2, so it's starting at 1, it's subtracting 2.
Let me circle an important piece of information here. Geometric. So you don't add to get geometric, you multiply.
That's
Ridiculous.
ridiculous.
That's ridiculous. Okay, here, I'll give you a hint.
Well, because now I have to do it all.
Okay, here. Okay, so we have
So the negative 10 is 2.
n, a sub n. So a sub 7 is going to be 5. And we're trying to find a sub 10.
Ace of 1 is negative 320.
A sub 1 is negative 320. We want to find A sub 10. So I'll give you another piece of information. A sub 8 is going to be negative 10.
Oh my God.
Would that mean 9 is positive 15? No, positive 20.
Positive 20. Base of 10 is negative 40.
Yeah, negative 40. See?
Um,
Yeah, so that's it. Okay, good job. See, you worked with it. That's the way class is supposed to work. Good job for working the way class is supposed to work.
So you just base of 10 is negative.
Yeah, so that's it. Okay. So now, I'm gonna try to remember what 8 is here. Okay, let's see here. Yeah, I don't want to do these. Okay, I want to show you 9. Okay, just because the first 5 terms of the sequence n squared, so this is sort of like an instructive piece for this today. Okay, what we have, the first 5 terms of this sequence, we can take 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared, right? And we can add all those up together and we will have, now when we talk about sum, we call that a partial sum. We call it the 5th partial sum. And what you can do is that can be articulated like this. You can put this summation thing, and you can start out with k, or you can start with n, is equal from 1, and 1, 2, 3, 4, 5, up to 5, and then that's going to be k squared. And so what this is telling us, this is the notation for doing all this right here. It's called a sigma notation. And I don't know if you've already added this up. It's quite easy to add up, being the numbers are pretty small. But I want to show you how to do this in the calculator, because this is going to be helpful, not to this problem so much, but to future problems. So in your calculator, which I don't have queued up yet,
Is our exam going to be easy?
your exam is going to be, it's going to be in degree of difficulty, it's going to be similar to the last exam, but it's going to have, we're going to have a packet that covers all the types of problems that are on it.
How many questions?
I think it's going to be 30 or 32, something like
Are
that.
you gonna make a video like the last time, like the last review packet you gave us?
No, but what I do is I have videos for the problems on it, like separate little videos. So anyway, we do is we go here and we go to math, and I have to remember what they are here. It's one of these things I have to remember where it is.
I think it's under math and 0.
Math 0. There it is, yeah. It's math 0 right here. So you go right here and you start, and you can use different letters for this, but I like to use, typically you see K or N used. So I'll say alpha, K, you could use any letter. So K equals 1, and we go all the way up to 5. And over here we put in K squared.
No, but where did you get 1?
Okay, I'm going to show you in a minute. But here you put K, here's K, and we square K right here. Okay? And the question, where was 1? Mm-hmm. 1 represents the first term. So what this is, this is summing up terms 1, 2, 3, 4, all the way up to 5.
So the end number goes on top and then the number you're starting at.
Right,
at the
uh-huh.
bottom.
And the number you start. And the way I like to do this, I like to start with either, sometimes it's easier to start with 0 to this high number, but I want to go back to, well, let's just press enter, so we get that answer. Did anybody add it up? And that's what you got, right? So this is going to be a go-to thing, and actually there's 1 or 2 problems on the test that puts the problem, this notation, such that all you have to do is enter in the calculator, and then you have your answer. Okay, and then similarly here for problem 10, the first 5 terms of the sequence, how would you do that? How would you do the first 5 terms of that?
Put 5 on top.
K equals 1, put 5 on top, and then over here, you just put 2K minus 1. And then you just put that in the calculator, you have your answer. And Nicole, in our calculator, the place of honor is we had to remember where it was. You go to math, and you scroll down to 0.
You see 2K minus 1.
Get 2K minus 1. So you start with K equals 1. Where's my K? And you can use different letters
So
too.
just use X.
I think you could use X too. I think you could use X equals 1. I haven't tried that. I'll try that because that would be helpful. So is 2K minus 1? I'm going to try Nicole's suggestion about that too.
Yeah, you can. I got the same reaction.
Oh, she did? Okay, so you use, and the advantage of that is you can just press the X key.
Yeah.
Okay, so that's the shortcut. So Nicole saves us a couple of keystrokes, okay? So anyway, that's that exercise set. So I want to get started on the next one. We're not gonna finish this, but at least we'll get started on it.
Have you ever done a Jeopardy game before?
Hey, what?
Jeopardy game?
Jeopardy game? No, I haven't.
Have you ever made a Jeopardy game?
Robert.
Class?
I haven't made one. They can be made.
Yeah, I'm making one for Spanish and Mexican.
Are you?
Which one?
You're making it for the Spanish speakers.
So we'll just get started on this today.
We have 4 minutes.
That's about what we need to do.
Just the back.
Yeah.
What do you want?
Good. All right. So here we are. Yeah, just have time to very lightly scratch the surface on this one. Okay, we get to the 9.5 exercises. And 1, write each sum using summation notation. So what you're trying to do is find out, you have to find out how many terms it has. So to write out in summation notation, you can start out with K equals 0, and what do we have to do to come up there? Well, you know a sub 1 is going to be -7 plus, and we look for our common difference. What's our common difference here?
Plus 4.
Plus 4, so it's going to be
No,
4.
it's not 4, it's plus 6.
6, okay, 6, thank you. 6, and so we're going to go up to, we don't know what yet?
33.
Well, I'm saying we don't know yet because we don't know what n is. Okay?
So, why couldn't we put -7 on the bottom of where it says K equals 0? with the starting point here.
Okay, so this is 0, 1, 2, 3, and to find out what this total thing is here, we can take 53 minus -7, and we're going to divide that by our common difference, which is 6, and so we get 60 over 6, which equals 10. What that means is that we have 10 between, if that's 0, we have 10 spaces in between. So we go from 0 to 10, and we go ahead and write that out. We're going to have -7 plus 6 times, actually it's going to be 6 times k. And that's going to give us our whole answer here. But that's the notation for it. You see why that works out? Because we plug in 0, we start out with -7. If we plug in 1, we get -6 plus -7 plus 6. If we plug in 2, we get -7 plus 6 times 2. And so basically this is our answer. And did anybody put this in a calculator? Where we can, not all these are going to be fit to be put in a calculator. $253? Okay, we're going to have to leave it there because of time. Thank you.